In this problem, we have a plate that lies on the unit square and has weight density 1 plus yx pounds per feet squared. What is the weight of the portion of this plate that lies above the line y is equal to x? So this is very similar to the previous problem, and I'm going to open up Desmos to look at it. So this square is the unit disk, and then if we look at the line y is equal to x, the part of the disk that is above this green line, so this portion right here, this is the portion that we are interested in. Okay, so we're going to do this two ways. We're going to integrate with the x integral on the inside and with the y integral on the inside. Okay, so if we integrate with the x integral on the inside, that means for every fixed value of y going from here up to here, x is going to go from the vertical line x is equal to 0 to the green line y is equal to x. So this means if x integral is on the inside, x is going to go from 0 to y. And the outer integral, what are the y limits? Well, y is going to go from 0 up to 1. So let me just point this out. I've said it before, I'll say it again, that the inner integral, the limits can be variable, but the outer integral, it cannot be variable. So the outer integral has to be constant, at least in terms of x and y. The inner integral, it's okay if the limits are in terms of the other variable. And then we're integrating the function 1 plus xy dx dy. And again, we just do the inside integral and ignore the outside integral. So the antiderivative of 1 plus xy with respect to x is x plus x squared y over 2, and this is x going from 0 to y. And this is the integral y equals 0 to 1, y plus y cubed over 2 dy. Now this is just a Calc 1 integral. I will let you do this on your own. The answer is 5 over 8. Okay, so this is how we answered the problem if we did the x integral on the inside. Now let's look what happens if we do the y integral on the inside. So now the y integral is going to go on the inside. That means for every fixed value of x from here to here, the y value is going to go from y is equal to x to the horizontal line y is equal to 1. Okay, and it's helpful to draw a picture like this. And in fact, if this was a normal class, in other words, not an online class, I would make you draw a picture like this on the exam to indicate what you're doing, just to make sure you don't get it by accident, and also because I think it's for your benefit. So y goes from x to 1, and then x, the x values go from 0 to 1. And the function that we're integrating is 1 plus xy dy dx. Okay, the antiderivative of 1 plus xy with respect to y is y plus xy squared over 2, and we're going from y is equal to x. Sorry about that. I'm a popular guy. What can I say? Dx. Okay, so this then is the integral from x, x is equal to 0 to 1. Okay, over here, when y is equal to 1, this is going to be 1 plus x over 2 minus, now y is equal to x, this is x plus x cubed over 2. And this is equal to 5/8. Now, you know that it should be equal to 5/8 because that's what the other one was equal to, And both of these integrals, whether you do the y integral on the inside or the x integral on the inside, both represent the weight of this part of the plate. But it's helpful to actually just compute this integral. It sort of gives you a check to make sure that you've done things right. I also want to point out that in this problem, I think it was easier to have the y integral on the to have the x integral on the inside and the y integral on the outside. Just because when we had the x integral on the inside, the limits were 0 to y, and those were easier limits to deal with. Now, this is an example of something that we'll see an even more, to an even greater extent later, that it's usually not, it is usually not the case that both orders of integration are equally easy or equally hard. There's typically one order of integration that's a little bit easier. How do you choose which order? Well, for some problems, there's really only one way that will work. For problems like this, both ways work, but it just sort of takes experience to figure out what is the best order of integration.